Hey folks, it's Mr. Young, and this is day 2 of nuclear chemistry. I'm going to take you through a little bit of a recap of transmutation, and then talk to you about two very important kinds of transmutation: fission and fusion. So first thing we're going to do is go over the half-page white exit ticket from last class. Here we go. Number one, which particle has a mass that's approximately the same as the mass of a proton? Well, a neutron and a proton both have a mass of 1 unit. You can find that in table O in your reference table, so you can figure out the mass of particles. An unstable nucleus loses the most mass if it emits an alpha particle, because an alpha particle has the most mass. It's got a mass of 4. Beta particle and positron, that's an electron and an anti-electron, they have a mass of 0. Gamma rays also have a mass of 0. Which subatomic particle is negatively charged? Well, you know an electron has a negative charge. A neutron is neutral. Positrons are anti-electrons. They have a positive charge. Protons have a positive charge. Which particle has the greatest mass? Hey, that's a repeat of number 2. An alpha particle has the greatest mass. Which particle has the least mass? Well, that is a mass of 4. This hydrogen particle, or maybe this is a proton, has a mass of 1. Neutron has a mass of 1. Hey, this electron has a mass of 0. Okay, number 6, a little more complicated. They're talking about hydrogen 2. That's called deuterium, and hydrogen 3, tritium, or these particles are called deuterons. These particles are called tritons. These are two isotopes of hydrogen. So in terms of subatomic particles, how does a deuteron differ from a triton? Well, all H have 1 proton, okay? But H2, let's see, H2 has a mass of 2, so it has H2 has 1 neutron. H3 has 2 neutrons. Okay, so there we go. That's how a deuteron differs from a triton, and we answered it in terms of subatomic particles. Okay, now let's have a look at that. Hit pause if you haven't done this warm-up yet. It's blue, it's a full page, and let's go through this warm-up. Okay, find the decay mode. You're going to use table N to find the decay mode for these types of isotopes. Calcium 37 looks like it has positron decay. Francium 220 looks like it has alpha decay. I'm just getting these from table N. Krypton 85 has beta decay. That's electrons, negative beta particles. And thorium 232 goes through alpha decay. Write the transmutation reaction for the decay of each of the following. So we have iodine 131, okay? And iodine 131 has a charge. Okay, look on your periodic table, figure out the charge. Charge is basically the number of protons. Okay, so it's element 53 means it has 53 protons. And then this goes through some kind of radioactive decay. Iodine 131, when you look it up on table N, that goes through beta decay. So what gets emitted? A beta particle, which has a mass of 0 and a charge of -1. Okay, so what will this be? We use the law of conservation of mass and conservation of charge. Whatever this is, it will have a mass of 131, because 0 plus 131 has to equal 131. And then it's going to have a charge. Well, on this side we have a charge of -1. This is going to have to be something with a charge of 54. That means something with 54 protons. And so let's see what element that is that has 54 protons. You look in your periodic table, find element 54. It's going to be xenon, because xenon is the element with 54 protons. That's what you use as your last step to figure out what this element is. Plutonium 239. Plutonium 239, first thing, look on table N, find plutonium-239, goes through alpha decay. Okay, this is one that's going to be easy. So we've got plutonium-239. Okay, figure out what is the charge of plutonium. And plutonium, where are you, plutonium? Plutonium, there it is. Has a charge of 94. It has 94 protons. It goes through alpha decay, so we could say it emits a helium nucleus with a charge of 2 and a mass of 4. And what is left over? Well, 4 plus something has to equal 239. So whatever this is, it has a mass of 235. And then 94 has to be equal to 2 plus something. So this is going to be equal to 92. And that is good old, where is it? Where's good old, yes, it is good old uranium. Uranium has 92 protons, so it has a charge of plus 92. So there we go. Fill in the missing particle. Okay, this one is easier. These two particles are being smashed together. Francium and something makes this particle. 87 plus what makes 89? That has a charge of 2. 220 plus something makes 224. And 4, oh, well, this is helium, or you could draw it with an alpha symbol there instead of the He. Okay, gold 198 decays to produce mercury 198 plus something. Well, whatever this is, it has a mass of 0, this particle, because 0 plus 198 equals 198. 79, 80, this has to be something with a charge of -1. -1 plus 80 equals 79. So this is a beta particle. You could also have written this like this, because that is an electron. Okay, which one of these is artificial transmutation? In artificial transmutation, humans slam two particles together. So A is artificial transmutation. Why? How do we know? Because there are two reactants. You take some sort of stable particle and slam another particle into it. That's how humans do artificial transmutation. Natural transmutation happens naturally to unstable isotopes, and there would just be one reactant in natural transmutation. Okay, multiple choice, number 5. A change in the nucleus of an atom that converts it from one element to another. Hey, that's transmutation, turning one element to another. What particle is emitted from a hydrogen-3 nucleus when it undergoes radioactive decay? Use table N, okay, and find hydrogen-3. It undergoes beta decay, okay? Beta particles or electrons. That's right from table N. That's hydrogen-3. A beta particle may be spontaneously emitted from which of these? A ground state electron? No, electrons don't emit beta particles. A stable nucleus? Well, stable nuclei don't emit particles. They're stable. An excited electron? That's just a subatomic particle. Aha! An unstable nucleus is what might emit a beta particle. That's radioactive decay. Unstable particles, unstable nuclei emit beta particles, positrons, alpha particles, etc. Identify particle X. Okay, we have to obey the laws of conservation of mass and charge. 2 plus 3 on this side, 4 plus whatever this is, it has to have a mass of 1. 1 plus 1 on this side, 2 on this side, it has a charge of 0. Okay, the only particle I know of that has a charge of 0 would be a neutron. They're listed there in table O. Okay, we don't come across these too often in radioactive decay, but neutrons can be emitted as a type of radioactive decay. And we know that this thing has to be something with a mass of 1 and a charge of 0. The only thing that fits that is a neutron. Okay, complete this nuclear equation. Cesium-137. Okay, we're obeying the laws of conservation of mass and charge. Whatever this is, has to have a mass of 137. And then the charge on this side has to equal the charge on this side. 55 over here, -1, and 56 over here. So if we look in our periodic table to find, okay, what element